Okay, we're going to take a look at a couple more exponent rules now. So the first thing we're going to have to figure out is what is 2 divided by 2? And the answer is 1. Okay, you can type this into your calculator if you'd like. 147 divided by 147. The answer is 1. Okay, when you divide, it's like canceling and then you make a 1. Now, you can't type m's into your calculator, but maybe we could figure out, okay? If we have same divided by same, the answer is 1, right? So m to the 5th divided by m to the 5th, the answer is going to be 1. Okay, but some people might be thinking, well, wait a minute, aren't we supposed to subtract the powers? Aren't we supposed to say m, since they're both m's, you take the 5 power and minus the 5 power and make a 0 power. Okay, and that's true. And so there's something weird that happens here. If there are no m's left, then the answer is 1. Kind of like here. There were no numbers left. You divide 147 by 147 and we get 1. Okay, so here is the new rule. I could do this the long way or the short way. Okay, and so if I have same divided by same, the answer is going to be 1. But there's a negative this time. Okay, or maybe we could use the rules. I'll write negative, and then how many x's are there? 3 minus 3, 0. There's no x's, then there just must be the negative 1 left over. Okay, so what's the pattern that we're noticing? Anything to the power of 0, anything to the power of 0 is going to make a 1 because it totally cancels out. I could write this out the long way, I guess. I could write 1, 2, 3, 4, 5 m's, and I could write another 5 m's. And the question is how many cancel? M divided by m makes a 1. These cancel, these cancel. There's the exact same amount, and so the answer is 1. There's 0 m's, and so we just have a 1. Okay, now we're going to use that observation to figure some of these out. Okay, what if I have x to the 0 power? There's no x's. There's no x's. And so the answer would just be 1. There's just 1 left. Not 0. Not 0, because remember we said up here, 2 divided by 2 makes 1. All right, right here, all of this stuff is to the 0 power. Anything to the 0 power, the answer is just going to be a 1. All of that stuff has the 0 power. Now what we could do, someone could say, well, shouldn't I give negative 5 the 0 power? Yes. And then shouldn't I give x the 0 power? Yes. So negative 5 is going to turn into a 1. And then x has a 0 power, so he turns into a 1. And everybody turns into a 1. All right. These are the two easiest rules that we're going to learn here. I've got x to the 100 power, a power to a power so powerful we multiply. Okay, so what we have here is negative x, and a power to a power makes a 0. So there's 0 x's. So the answer is not 1 because of this negative sign, so it's going to be negative 1. Okay, so don't go 1 crazy and make everything turn into a 1. Only the stuff with a 0 power. Okay, here the answer is not 1. We have to be very careful. X has a 4 power. Okay, Y, oh Y, you sneaky dog, you have a 0 power. And Z has the 5th power. So Y is going to turn into a 1. But x to the 4th, he's going to stay, and z to the 5th power is going to stay. If you'd like to write a 1 out in front, you can, but you don't have to. Okay, so not everything is turned into a 1. Only variables with a power of 0 turn into a 1. Okay, only the variables that have a power of 0 turn into a 1. Okay, so the first rule we're learning today is if you have a 0 power, you turn into a 1. Now there is a way to check this on the calculator. Okay, if you forget this rule, have no fear. Okay, we'll just take out our calculator and I'll type 5 to the power of 0. I forgot what the answer was. If you have a 0 power, you turn into a 1. If you have 100 to the 0 power, you turn into a 1. Okay, now watch this. 3 times 5 to the 0 power. Okay, what's that answer going to be? It's not 1. Okay, does 3 have a 0 power? No. Okay, 5 turned into a 1, but 3 did not. 3 times 1 makes 3. So you could always check some knowledge with your calculator to remind yourself of this rule. Okay, all right, let's do the second rule of the day. And here we have a lot of m's. Okay, so let's do this the short way and the long way. So what we're going to do here is, are we going to multiply these powers? No. Should we add these powers? No. Remember what to do? The rule says you subtract. We're going to subtract. And does it matter how we do it? Yes, we're going to take the top power minus the bottom power. So we're going to do 3 minus 7. Okay, so the answer is m to the power of, it's not 4, it's negative 4. Oh, that's weird. Negative 4. All right, what's the long way? We can't do this with our calculator because there's letters. So maybe what I'll do is I'll draw 3 m's on top. And let's do 1, 2, 3, 4, 5, 6. I'll put 7 m's in the bottom. Okay, so I'm going to cancel some m's. How many m's are going to cancel? 1, 2, 3. How many m's do we have left? And the answer is 4. But where are they? They're in the denominator. So I have to write 1 over m to the 4th power. Okay, they're left in the bottom. Does that make sense? Were there more m's in the denominator? So look at what happened here. When you subtract and get a negative exponent, that means the m's are from the bottom. The m's are from the bottom. If the exponent is negative, that means they actually belong downstairs. Let's do it again. Let's do it the long way. Let's draw 2 x's on top. And we'll write 8 x's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the long way. I would cancel 2 sets of x's, and how many x's are left? And the answer is 6. Okay, but I don't write x to the 6. That's wrong. That's wrong. They're from the denominator, so you have to say they're downstairs. Now, if you do this with the rule, algebraically, you would have to take 2 minus 8. 2 minus 8. The order in which you subtract the powers matters. And so the answer is x to the power of negative 6. Here we go again. If you get a negative exponent, that's because the x's belong in the denominator. Okay? All right, let's do this last one here. This one's kind of weird. We got numbers and letters. Okay, so we have 3 divided by 6. I'm going to draw a fraction bar. And the answer is 1/2. Okay. X's. I see a 5 minus 3. So 5 minus 3 is a positive 2. Those x's are going to stay upstairs. 5 minus 3 is 2. They're going to stay upstairs. That's like yesterday. Okay, but this is where it gets weird. I've got y to the 2 minus 7 power. That's negative 5. So where are we going to put them? We're going to put them downstairs and say that there's 5 y's downstairs. Does that make sense? Were there more y's in the denominator? Yeah, so that's where the leftovers go. All right, so what's this rule? Okay. If a variable has a negative exponent, put the variable in the denominator. Put it in the denominator with a positive exponent. Put it in the denominator. So if you subtract and get -4, that means they belong downstairs. Okay? If you get -6, that means that there's 6x's downstairs. Okay, so this next one right here, I've got x to the -1 power. So that means that there's 1x. There's 1x, but you have to write it in the denominator. You could write x to the first power. Do you see why I moved them to the bottom? Because the negative exponent changes to a positive. When we move a variable, its exponent becomes positive. Very important. We're going to move it, and then the exponent becomes positive. So who do we move? Only the variables that have negative powers. What's the exponent on 5? It's invisible. It's just a 1. Okay, so 5 does not have to move. 5 is going to stay in the numerator because he's got a +1 power. But this little guy right here, okay, x, he needs to move. So we're going to take x, put him downstairs, make the power 2. Why did 5 stay upstairs? Because his exponent was a +1. We don't move everybody. We only move the ones with negative powers. Okay, what are we going to do here? I see x with a negative power, okay? Negative powers, they need to move. X needs to move, but he already is in the denominator. So where am I going to move him? Hey, I got an idea. If they're already downstairs, we're going to move them upstairs. X, you get to be upgraded. You get to go in the numerator. So x goes upstairs, and his power is a +3. When we move a variable, the exponent becomes positive. Okay? If in the denominator, if you're in the denominator, then move to the numerator. So do you always move downstairs? No. Do you always move upstairs? No. It depends where you start. If you start in the numerator, then you get moved downstairs to the denominator. If you start downstairs, you get moved upstairs. And that's only because your exponent is negative. So let's take a look at this last one here. We're not going to go crazy and move everybody. Okay, 3 has an exponent of 1. That's fine. X has a power of 1, so he's fine. These guys don't have to move. But Y, I'm so sorry, you have a negative power. Y is going to have to move. So let's draw our fraction bar and do this one step at a time. 3 is going to stay upstairs. X is going to stay upstairs. Y, he has a negative power, so he's going to move downstairs. And then what kind of power do we give him? A +4. You give him a +4 power, and that's how you know how to move things. Okay, I'm going to show you these couple of rules one more time right here. We have page 13. Let's skip page 12 and go right here. Okay, this is the first rule. Let's zoom in just a little bit. Okay, so who gets the 0 power? Okay, everybody gets the 0 power. Okay, so x, you're going to get a 0 power. Y, you're going to get a 0 power. And z, you're going to get a 0 power. Now the question is, what happens when you have a 0 power? If you forget, your calculator can remind you. If you have a 0 power, like 2 to the 0 power, you become, oh, that's right, a 1. Okay, so x is going to become a 1, and y is going to become a 1, and z is a 1, and the answer is 1. Okay, is that true? Did all of this stuff have the 0 power? Okay, then you could have said that that all turns into a 1, since it all had a 0 power. All right, just make sure you look carefully to see who has the 0 power. Taking a look at this one here, everything doesn't turn into a 1. Only the things that have a 0 power. Does 4 turn into a 1? No, a 4 is a 4. Okay, what about this stuff here? This stuff all has the 0 power. So that's all going to turn into 1. You could say 4 times 1 makes 4, or you could just say 4. Now, if you wanted to do it the long way, you'd say 4 to the first power, and then 2, you're going to get the 0 power, and x, you're going to get the 0 power, and so this guy turns into a 1, this guy turns into a 1, and all we have left is 4. Long way or short way does not matter. Okay, we're going to keep going down here. Number 3. Number 3 doesn't have any 0 powers, but we have a negative exponent. Okay, do they both have negative exponents? No. 3 has a power of 1, and x has a power of negative 2. Okay, remember, move those with negative powers or negative exponents. Okay, so I'm not going to move the 3. Let's draw your fraction bar. 3, you're going to stay in the numerator just like you are. But x is going to have to move into the denominator, and then I'm going to say x to the power of, you have to change the negative 2 into a positive 2. Okay, you only move those with negative powers. And then, after you move them, okay, that's step 1. Step 2 is make the exponent positive. Okay, let's do the last one. We'll use that rule. Okay, 7 has a power of 1, so he's good. X has a power of 2. So I'm going to draw my fraction bar. He's good. I'm not going to move the 7, and I'm not going to move x squared. Leave them in the numerator like they are. Now what about that y? He has a negative exponent. So is he going to stay in the denominator? No. Is he going to move up to the numerator? Yes. If you're downstairs, you move upstairs. If you're upstairs, like this one was, then we move you down to the denominator. So y, get up here. Get up in the numerator. And then I'm not going to write his power as negative. I'm going to write it as a positive. Okay? We're going to give people a chance to write all these notes down, and then we're going to do the next page together. Okay? So make sure your notes look good.